Hi. Hi, this is Michael DePaul, your tutor here from the Science Learning Center in Tarrant County College Southeast Campus. And what I'm going to show you today is how you write an ionic formula when you're given the name of an ionic compound. Now in this case, the two compounds that we're given are sodium sulfate and ammonium phosphate. Now the first thing to do here is to make sure that you correctly identify the ions in the compound. So for sodium, you should look up on the periodic table, find sodium. You'll notice it's in the first column, third row, and the symbol is Na. And if you remember from your professor, all elements in this column have a +1 charge when they form ionic compounds. Sulfate is one of those polyatomic ions that you have to memorize, or, at least for now, look up from a table of polyatomic ions. Sulfate has the formula SO4, and it has a charge of 2-. Okay, so now you have the ions written, and you want to write an ionic formula. So what you want to do here is find the lowest common multiple of the charges. So sodium is a +1, we just put a plus, but I could put a +1 to indicate there, and sulfate's a -2. So we're looking for the lowest common multiple of 1 and 2. So I set up a little lowest common multiple chart. I can do that right here. So lowest common multiple for +1, or 1, is basically counting by ones. 1, 2, 3, 4, etc. Lowest common multiple for 1 and 2, now I have to look up the multiples of 2. So multiples of 2 would be 2, 4, 6, 8, etc. Okay, so now that I have my two columns of multiples of 1 and multiples of 2, I can look for the lowest common multiple. The lowest common multiple will be the one that appears first, and will be the lowest number, obviously. So in this case, you can see that 2 is the lowest number that appears in both columns. That's your lowest common multiple. So then you ask yourself, okay, so how many sodium +1 ions would I need to form a total of 2? A total charge of 2, that is. And so +1 times what gives you 2? Well, that'll be 2. So I'm going to write Na2. And then how many sulfates am I going to need to get a total negative charge of 2? Well, since sulfate has a -2 charge, I only need 1, right? So sulfate I would just write as SO4. And that's it. So the formula then would be Na2SO4. Notice something very interesting. When you set up the two columns to find the lowest common multiple, this is the second multiple of 1. So the second multiple of Na, so that means you need 2 Nas. And this is the first multiple of the charge of sulfate, so you need only 1 sulfate. It sets up very nicely that way. Okay, so let's take a look at the next one. Ammonium is a polyatomic ion from your polyatomic ion chart. It's NH4 with a +1 charge. Phosphate is also a polyatomic ion, not on the periodic table. And you can tell this from the ATE ending. Anytime there's an ATE ending or an ITE ending, you know that you need to look at your polyatomic ion chart. So PO4 has a 3- charge, and NH4 has a +1 charge. So you can then, at this point, look for the lowest common multiple. So my charges are 1 and 3. I'll set up my two columns, and it'll be 1, 2, 3, 4, etc. And 3, 6, 9, 12. So notice when I say multiples of 3, basically all I'm doing is saying, okay, so 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. So those are multiples of 3. So 3, 6, 9, 12, those are multiples of 3. You're basically adding 3 each time. Okay, so now that I see my 2 columns of multiples, I can simply go ahead and circle the lowest common multiple, which in this case is 3. Notice it's the third one down. It's the third multiple of 1, but it's the first multiple of 3. And that means, basically, I only need 3 ammoniums, but only 1 phosphate. So now whenever you need more than 1 polyatomic ion, it is imperative that you put a parentheses rather, around the polyatomic ion. So think of it as doubling or tripling the recipe. I need to double or triple everything inside the parentheses. So I put a parentheses around it, and then I need 3 of them, so I'll put a little 3 there. And the phosphate is PO4, and I only need 1 of them. So if you only need 1 polyatomic ion, you can just leave it as is. Alright, so then all you have to do at this point, write your answer, and you're good. NH4, 3, PO4. Now, you may have been taught in class the crisscross method. And basically the crisscross method is kind of trying to do a cheap and easy end around where you don't actually have to think about anything or calculate anything, you just swap the numbers. So there'd be 1 sulfate and 2 sodiums. But the problem with the crisscross method is that it leads to a lot of confusion because charges are not the same as subscripts. The subscripts actually, so these are the subscripts. The subscripts actually tell you the number of atoms. So they tell you the number of atoms. I have 4 atoms of oxygen here, and I have 1 atom of sulfur. Whereas the superscripts, the charges here, tell you the overall charge of the atom, which is basically the protons minus the electrons. So it basically gives you a proton-electron ratio, and it doesn't actually tell you how many atoms you have, it just tells you how many electrons you've lost or gained, basically. And so when you cross them like this, it can lead to conceptual confusion. You can think of these charges as actually being numbers of atoms, but they're not. So numbers of atoms are the subscripts, charges are the superscripts. Don't get them confused. Also, another problem with crisscrossing is that it doesn't always work. Sometimes it will not work and it will give you the wrong answer. So there's several different reasons why you do not want to use the crisscross method. Now I realize that this may take a little bit more work, but this, ultimately speaking, will make a lot more sense. And it'll help you when you're trying to name compounds based on the formula, especially more complex compounds that have Roman numerals and such. And we'll show you how to do that in our next video. Well, I hope you've enjoyed our video on how to write ionic formulas given a name. And we look forward to seeing you down here at the SLC. Have a great day. Bye-bye.